everybody. We're presenting our capstone Slender Threads. My name is Reddy.
I'm Rohit.
I'm Andrew.
I'm Allison.
And our client and advisor is Allison.
So, brief overview of our project. We decided to create a non-linear horror puzzle game. And the premise is that a couple of your friends are locked inside the school, so you're going to help them. And while you're trying to help them, there's this mysterious entity that's following you around. So you're trying to figure out why this entity is following you while helping your friends.
So we approached the problem of contrasting the nonlinear method of interactive storytelling with the continuous narrative of authorial plot design. This pairing is ostensibly divergent in that the author cannot make the player's choices for them. We endeavored to emphasize a particular focus on giving the player a multitude of decisions which lead to different experiences and endings.
So our solution was to take all these ideas and create the game. We wanted to keep the nonlinear storyline and nonlinear progression. And not only does the player have an overall effect on the outcome of the game, but they can choose wherever they want to go. They're not stuck on a basic linear path.
So the tools that we used were Autodesk Maya for our 3D modeling, Unity 3D for our dedicated game engine and scripting, Adobe Photoshop for dedicated texture software, Skype for our communication, group meetings, and Dropbox for collaborating with all the different files that we were using, and then obviously Google for just looking up all the random details we needed for this game, and then finally lynda.com, which has a massive tutorial database that was really crucial in learning how to do all of this.
So in terms of developing for Slender Threads, there were several sort of layers of development that we would need to work through before we would be able to, as a group, move on to the next set of steps. So you can see what we would kind of have to go through, and this is the general order of things that we would work through, but the order that's listed here doesn't necessarily dictate a strict order that we would always work with. So for example, we have research listed up here first. We wouldn't ever stop researching things. So as Rohit mentioned earlier, there was always tutorials to look up online. So whether it was related to scripting, modeling something in a certain way, or gameplay concepts, we would always be looking for things. And the time that we would actually spend going back and forth between these steps and collaborating with each other would better suit our needs in the long run.
So character modeling is a pretty extensive process. Character modeling animation, I should say. You start off by manipulating a polygonal model in Maya. So this could be any geometric shape, a cube or a sphere. Generally, you want to start with the cube. So yeah, once you have your object sculpted and manipulated to, in this case, it's a female bipedal girl that we modeled. Once that model looks approximately like what you're trying to go for, then you want to texture it, which requires UV mapping, which we'll go into the next slide. And then so once you UV map it, you texture it in Photoshop, and then you have yourself a textured model. After that is the really hard part where you have to animate. Animating is a multi-process ordeal. You start off with rigging. Rigging is really time-consuming. You basically create a skeleton. In this case, since it's a humanoid figure, it's an actual skeleton. You're putting it inside of the mesh. And so this skeleton will be used to animate it later on in the process. But for the time being, you create the skeleton, and then after you do that, the joints are what you're moving. So what you're going to do is, as you can see, these squares and circles around the model right there. Those are called controllers, and they make the animating process a lot easier, but they're hard to set up. So you basically constrain these controllers to specific joints to animate it have a lot more control, because the joints themselves are are not that tiny, but they're relatively small and hard to manipulate. So the controllers help with that. So once you have that set up, then you can bind the skeleton to the mesh and then finally animate. So, and then animating is this whole other thing that takes forever.
So first step of modeling game assets is to identify the need for a prop or object, such as a desk, a bookshelf, something like that. Next, the polygonal mesh is created and a shader is applied. That defines how the light reflects off the object. After that, a UV map is created to build the object's texture in. A good way to conceptualize this is to think of a bear skin. While the skin is wrapped around the bear, it's bear-shaped. But after you skin the bear and place it in front of the fireplace, it's a flat two-dimensional rug. Similarly, the UV map is a two-dimensional plane while we design the texture in Photoshop, and a three-dimensional entity after it's essentially wrapped around a game object in Unity.
So within Unity, we would actually start to build the game environment itself. So we would have to import all of these fabulous game assets that my colleagues had made. So this was the point at which everything would start to kind of come together, and we would start making basically everything and placing all the objects where they should be. So one of the most important parts of this step actually was getting all the scripting and everything else set up as well. So we would actually have to also take into account the player choice feature, which we wanted to design with. And we would need to set up each of these individual scenes really, really carefully so that each scene would correctly carry over to the appropriate scene as to supplement player choice in the way that we wanted to. And we would also begin to add all these narrative elements that we wouldn't be able to work with prior. So any dialogue between the characters, we have text messages that go on in the game, so all that written dialogue, all this would begin to come together here, as well as all the scripting gripes that we had with JavaScript and that lot.
So what we learned, this entire process was a huge learning experience for us. All of us came into this project with some modeling and texturing skills, but we're all basically beginners, and none of us had prior Unity experience whatsoever, which ended up becoming a huge hurdle for us to jump. Mainly because none of us are scripters, none of us know how to script, so it was that was a huge ordeal for us, just figuring out how to do that. I think time management became a major factor that we ended up we realized we didn't have as much time as we would have liked halfway through the first semester of this school year, mainly because for developing a game, any game is a huge undertaking. It's pretty large in scope. There's a lot of factors that go into it. So we probably should have had, at least a basic demo and a concept done before going into this school year. So over summer we should have already had a lot of stuff done, but we didn't really know what we were doing. So we came into it without any of that kind of ready, and we were already behind day one. So that wasn't helping our situation too much. So basically, time management became a huge factor for us, just mainly because we were behind the whole time. And so that's where project management came into play and helped us out a lot. We allocated jobs to each individual group member. And by splitting up the workload and then each working on different aspects of the game, it helped us put the game together a lot more quickly, and eventually helped us actually complete it on time. So thanks to allocating the jobs, that really helped. So thank you for your interest in our poster, or in our presentation. Please visit us in our poster session, room 120, to play our game.